This video is for lesson 6 of the waves topic entitled Light and Reflection. By the end of the lesson you should be able to recall that light is a wave and can be absorbed, transmitted or reflected, understand how two types of reflection can occur, understand and apply the first law of reflection, and then finally recall the properties of an image in a plane mirror. The first part of the lesson is something that we met in year 7. Nevertheless, you need to know this for GCSE, so could you put the title in your books? When light hits an object, it can be. And remember, wherever you see this red note here for your notes, you need to have whatever's on the slide into your books. Okay, so you can pause the video and make a copy of this after I've talked through it. Okay then, so if we consider this to be a beam of light coming in, then it can do one of three things. It can be absorbed by the material, so the atoms, molecules that make up the material absorb that light. It can be transmitted, it will pass through without any effect on the material it's gone through, or it can be reflected. Please note that any light that is absorbed by the material actually goes up to heating the material. In most cases you won't notice the heating effect, but there is some heating effect there. Can you pause the video and make a copy of that diagram? Okay, new title, Reflecting Light. This is also for your notes. So we've said that light can be reflected by an object. There are then two types of reflection that can occur, specular and diffuse. Specular reflections are the type of reflections that you see in a regular mirror. The image that you get is nice and clear and sharp, and is produced because the surface of the mirror is smooth. So here we have the rays of light coming in, which are referred to as incident rays, and they're reflected like so. And notice the rays are all reflected parallel to each other, so you get a nice sharp image of the object that you're looking at over here. The other type of reflection is a diffuse reflection, and these tend to be blurred. So if, for example, you look at a reflection of something coming through the window on a desk or a bench, you will be able to see the light hitting that bench and coming into your eyes, but you won't be able to see a clear image, and that's because the image is produced by a rough surface. So here the incident rays come in, and they're all parallel when they come in, but they're reflected at different angles out, so you don't get that nice clear specular image. Okay, can you pause the video and make sure that you've got good accurate diagrams of those two types of reflection. For the main part of your physics, you'll need to know about specular reflection, and you'll need to be able to reproduce a diagram like this and apply a rule, which I'm going to talk you through at the moment. Let's see if we can label the diagram first of all then. The reflected ray is the ray which bounces off the surface, so that there is going to go with number 5. The incident or incoming ray is the ray that comes in or hits the mirror, hits the reflective surface. Then you've got a line here, which again you met way back in year 7. It's called the normal, and it's an imaginary line which is always at right angles to the surface, right angle to the mirror, where the incident ray hits the mirror. So that's our normal there. The angle of incidence is the angle between the incident ray and the normal. Likewise, the angle of reflection is the angle between the reflected ray and the normal. And of course this line here with the shading on here is a mirror, and if it's a flat mirror we call it a plane mirror. Okay, it's important again that you get that diagram into your notes accurately, making sure this is a nice perfect V. Can you pause the video and do that now? Okay, there's one thing to add on the bottom here. For a perfectly flat surface, for a perfect specular reflection, the angle of incidence here is always the angle of reflection. So if that angle there is 35 degrees, the angle there will be 35 degrees. If that was 10, that would be 10, and so on. Please make sure that you've added that note to your diagram. Okay, in the last part of the lesson we're going to look at the properties of an image in a plane mirror. How does the image compare with the object that's reflecting in the plane mirror? So our object is going to be a light bulb, and here is our viewer, the person who's looking in the mirror. And in order to see that light bulb, rays of light have got to pass from the object into his eye. Now it could go straight into his eye like that, but we're going to use a mirror here. So a ray of light might come from the top of the object, hit the mirror and bounce off. Now if this is a perfectly smooth mirror, then the law of reflection, the first law of reflection applies. The angle of incidence is equal to the angle of reflection. You've got this perfect letter V there. Okay. Right, let's add a second ray, this time from the bottom of the object. Okay, so that's going to do a similar kind of thing. It's going to come, hit the mirror, obey the first law of reflection, and then enter the person's eye like so. Now, when you look into a mirror, the image that you see of the object always appears to be behind the mirror. And it's a trick of the eye, really, or the brain, I should say, really, because your brain believes that light always travels in straight lines. So it believes that the object is over here, like so. So your brain, if you like, fills in the gaps. So you observe the image over here. And if you follow the lines down and you measure this distance, here, here, then you'll find that the image always appears to be the same distance behind the mirror as the object is in front. So if you stand and look at yourself 30 centimeters in front of the mirror, you're actually looking at yourself 60 centimeters away because the image appears to be the same distance behind the mirror. You'll notice that for a perfectly flat mirror, the image is the same size. It's upright, which means it's the right way up, it's not inverted. We've already talked about its equal distance behind the mirror, and this term virtual is a tricky one to get to grips with. Because the brain is tricked into thinking the light bulb's over here, real rays of light don't actually pass through the image here, they just appear to come from them, so we call that a virtual image. Okay, to summarise that then, could you get this into your notes? Properties of an image in a plane mirror. The image of an object in a plane mirror is upright. It's the right way up, it's the same size, it's virtual, real rays don't pass through the image, and it is, one thing I forgot to say, it's laterally inverted, it's back to front. Now you can't see that from the diagram that you got there, but it's something that you will know from personal experience. So make sure please that you've got those 4 points written down in your book. Okay, you should now know that when light encounters an object, it can be absorbed, and it can be used to heat the object. It can be transmitted, let through, or it can be reflected, bounced off. You should understand that a diffuse, blurry reflection is produced when light hits a rough surface, and that a specular, clear reflection is produced when light hits a smooth surface. You should understand that for a specular reflection, the angle of incidence is equal to the angle of reflection. Remember, those angles are measured with respect to the ray and the normal line. You should be able to recall that in a plane mirror, a flat mirror, the image is upright, the same size, laterally inverted, real, and it is also the same distance behind the mirror as the object is in front.